Sir, start the session, sir.
Yes.
Sure, sir. Thank you, sir. Thank you, sir. It is my absolute pleasure to welcome you all again to session 6 of Atal Online 6 Days FDB, organized by SRM Madurai College for Engineering and Technology. This session promises to be an enriching experience as we share into the topic electrical drive technology for EV applications, an area of immense importance in today's rapidly evolving technological landscape. So we are honored to have with us eminent expert Dr. B. Chettibabu, Associate Professor at Indian Institute of Information Technology, Design and Manufacturing, Kanjipuram, Chennai. Dr. Chettibabu is a dynamic academician and researcher with an impressive career spanning over 15 years in prestigious institutions and international collaborations. Sir completed his PhD in electrical engineering from National Institute of Technology, Rourkela, and has held several esteemed positions, including appointments at Warkla University of Science and Technology, Poland, and the University of Nottingham, Malaysia. His research contributions have been recognized globally with numerous awards such as Young System Scientist Award in 2019 and the IEEE Madras Section Best Research Award 2021. He is not only an eminent professor, having received the Outstanding Teacher Award in 2023 from IITDM Kanchipuram, but also a skilled researcher with over 70 published papers in reputed SCA journals, including IEEE transactions. His expertise spans power electronics, renewable energy systems, and smart grid technologies, making him the ideal speaker for today's session. Sir's dedication to advancing research and innovation is reflected in his leadership roles as editor-in-chief and associate editor for numerous peer-reviewed journals, as well as his successful completion of government-funded research projects. So without further delay, let us warmly welcome our honorable speaker to let us through this insightful session. Sir, we are eagerly looking forward to learning from your vast experience and expertise. Please, sir.
Thank you very much. So let me share my screen. Is it visible?
Yes, sir.
Just a minute, let me make it a full screen mode. Is it visible now?
Sir, only the Gmail is visible, sir. Gmail.
I see. Okay.
Yes, sir.
Okay. Actually, that is, let me take it. Now,
Yes, now it's visible. Thank you, sir.
Yeah. So now I have two windows.
Thank you, sir.
Is it visible now?
Yes, sir. It's clear.
Thank you very much for introducing me to the participants, and it's my pleasure and privilege to be a part of this Atal FDP on optimal design of electrical vehicle and fuel cell developments in fuel cells as well. And as I think number of speakers might have discussed about the topics on electrical vehicle in all aspect, as I am going to discuss about the electrical drive technology for electrical vehicles, and still people believes that electrical machines are quite outdated, as we could study during undergraduate, the course called electrical machines 1 and maybe electrical machines 2. In addition to that, participants might have studied about design of electrical machines. That would be a kind of the course followed by a textbook called Electrical Machine Design by A.K. Shah and Dhanpat Rai publishes, right? Yes. So do not feel that the electrical machines are quite exhausted and no more developments further. And since the inception of electrical machines, electrical generator, very first developed by Michael Faraday in the year 1831, right? It's almost it's over 2 decades, 2 centuries. So now we are in 21st century. That again, the trend has come to open a door for electrical vehicles with the electrical drive. So no more IC engines, and of course the electrical vehicles are going to play a very pivotal role in future transportations. They call it as intelligent transportations with EVs. They are going to be an autonomous vehicle as well. Of course, the credit goes to electrical energy. The credit goes to electrical. It meant electrical machines. The heart of electrical vehicle is an electrical motor. I mean electrical drive system. Right, I was talking about the current vehicle at what we uses with IC engines. Of course, the heart of the conventional vehicles are IC engines, maybe a 2-stroke or a 4-stroke engine having a petrol fueled or maybe a diesel fueled. right, or the CNG, but still now the trend is going to be changed with the electrical vehicles, right? As I said, this electrical drive or electrical motor is a part of electrical vehicle, as it is playing a very major role in providing a mechanical energy to the drive system, so that the wheels are able to drive the car from one place to another place, right? So with this, I got inspired with the title electrical drives technology, that the participants in the feel that the electrical machines are no more, and as what's the need to study again further, right? But now please understand that you are again going to study about the electrical machines because of this electrical vehicle. And talking about the introductions, of course, as all of us know, that the electrical vehicle is a type of vehicle that is powered by electricity, typically stored in the batteries rather than conventional internal combustion engines that rely on the gasoline or the diesel. As I said, the electrical vehicle is being powered by electricity. Typically, the electricity is stored by batteries. Right, and of course the batteries is a part of the electrical vehicle, and the battery is a source of power that feeds power to the electrical motor. Electrical motor is well connected with the drive system of all the wheels, so that the car or the four-wheelers can be able to move from one place to another place. Right. So as EVs are getting very popularity due to the environmental benefits, lowering the running cost, and advancement in battery and charging technology. Maybe after a couple of decades, you may find almost in the Indian roads, you may find about 70 to 80% of vehicles are EV. But it doesn't mean that it makes sense in replacing all the IC engine-based vehicle with the electrical vehicle. Almost is still the long way to go, right? Because it has a number of challenges in designing electrical vehicle. Of course, what are the challenges in designing electrical vehicle, and I am going to highlight a very small part of electrical vehicle, that how would you choose an electrical motor, right, as designing electrical vehicle, right? And how would you design such electrical motor for electrical vehicle application, because the electrical vehicle has a different mechanical and electrical characteristics, and choosing the right motor for electrical vehicle, still it is a challenging task. So I'm going to highlight here the importance of electrical machine or electrical motor in electrical vehicle applications. What are the typical characteristics of each and every electrical motor, including DC motors and induction motors and PMSL, so that based on that, how would you choose a particular motor for EV application? This is what the intention of this presentation. Of course, the electrical vehicles are being classified into 4 types, and the type 1 is a battery electrical vehicle. Of course, battery electrical vehicle, it meant the fully electrical vehicle powered solely by batteries. So it meant, of course, the dependence of energy is a battery. So battery, it fuels energy to the motor, so that it is the vehicle is able to move. They call it as BEVs. For example, Tesla Model 3 or Nissan, basically they are battery electrical vehicle. Right. The second category would be plug-in hybrid electrical vehicle. So that it meant that it has the combination of internal combustion engines with rechargeable battery. So that as during starting, as we use electrical motor, and during running we may use internal combustion engines, maybe and otherwise. Right. Example, Toyota Cruise Prime is a plug-in hybrid electrical vehicle. Let it be a hybrid electrical vehicle. So it has a traditional IC engine with an electrical motor, but do not plug in for charging. So it meant the battery is being charged through regenerative braking, and then the engine is being driving your vehicle. That is, for example, Toyota Cruise. It is a non-plug-in. And further, the EV is the fourth type of EV is called the fuel cell electrical vehicle. So it meant here hydrogen as a fuel to generate electricity. So that is being feed to the electrical motor, so that motor is able to drive your vehicle. For example, Toyota Mirai is a fuel cell electrical vehicle. Right. As understanding here, of course, the vehicle one is maybe a CNG. It's powered by gas engine, or it doesn't require any battery. And of course, the fuel source is a gas. That is a conventional gas. Of course, internal combustion engine having a transmission. Maybe the hybrid, as it added the battery along with the electrical motor and the battery, of course, it improves efficiency, because of there would be a great regeneration with the help of electrical motor. This is the conventional hybrid electrical vehicle, and the plug-in hybrid electrical vehicle that uses the motor along with the battery, but still the source of energy is electricity as well as gas. but still the vehicle is being charged through a plug-in, right? And then this is the typical electrical vehicle. Of course, it's a battery-powered electrical vehicle, and of course, it uses the largest batteries, and it doesn't require any gas engine and no tailpipe. Of course, it has a high starting torque and accelerating torque as well. So this meant for very long distances, and still the source of energy is what? Electricity that is being stored by the battery, right? Right here, the electrical drives is, the drive is an electrical motor. Right. So now, as understanding from the fundamental, as of course the motor is a part of the electrical vehicle, and there are 5 important components in electrical vehicle. Of course, the very first is an electrical motor. Right. So that electrical motor, as all of us know, that it simply converts electrical energy into mechanical energy to drive the wheel. Right. Of course, the electrical motor that gets energy from the battery. Of course, we call it as a battery pack. It stores energy, and then the modern EVs use a lithium-ion battery, or maybe a kind of solid-state batteries as well, or maybe a nickel-cadmium batteries as well. And further, the battery cannot feed straight away power to the motor. Of course, we need an inverter. If the electrical motor is an AC motor, or maybe either induction motor, or maybe a permanent magnet synchronous motor, and as we need the inverter, right? So that inverter, it converts the direct current or the direct power that is being supplied by the battery into alternating current for the motor, so that you are able to run the electrical motor, right? And further, as the inverter with the battery that is being charged, so once the energy is being discharged through the battery, then we need onboard charger, so that it manages the battery charging for an external power source. That may be through the typical 3-phase AC distribution system, maybe typically a AC grid, and of course the charging port that allows the EV to connect to a power source. This is what the port is, wherever we could find a charging station, we are able to plug the vehicle for charging the battery, right? And you understand from the schematic of the vehicle that it has 5 important components, right? And understanding the pros and cons of EVs, as you take it the positive way, that as all positives about the electrical vehicle, that it is very environmental friendly, because it do not cause any CO2 and greenhouse effect. Of course, it mitigate global warming as well. It is an alternate for climate change as well, right? And in addition to that, there would be a cost saving, right? Because as we promote the electrical vehicle, then the running cost is eventually reduced. So the lower energy cost and the maintenance cost as well, and efficiency. So electrical motors are very more efficient, and all of us know that it has the energy efficiency about 85 to 95% using any power electronics and based energy efficient motors, or maybe the energy diversity that use and renewable energy for charging as well, as that you make that energy independent, right? So these are all the positives about the EVs, but still, and it has a number of negatives as well. Maybe the charging infrastructure, because of the charging and the limited availability of charging stations in the countries like India, still long way to go develop a charging infrastructure, and the level of the road and the battery range. And this is a very important concern for any truck and over long distance traveling, maybe about 200 or 500 kilometers. Still, the battery range for the distance of EVs is still a challenging task, because the charging time is about 6 to 10 hours for charging the vehicle. Of course, it's a problem for a long distance electrical vehicle, and still the initial cost, it's a higher upfront cost because of the battery size that decides about 40% of your electrical vehicle. And another important challenge in promoting EVs is the battery recycling and raw material. This is a very important concern in today's. Even you use the battery for EVs, but still the battery recycling is a very challenging task. Still, it causes environmental concerns. All right, this is what now, and there would be a strong debate in the EV Mission. While I attended the EV Mission at the New Delhi during October 2024, there was a long debate about even you promote electrical vehicle, but the very challenge is the recycling of the batteries and the solar cells. Still, it is a challenging task, right? But however, as the initial cost it's quite higher, but now, and thanks to the battery technology, the batteries prices have dropped significantly. For example, in the year 2010, for 1 kilowatt hour battery, the cost would be about $1,200. I mean, it's about 1 lakh rupees in Indian rupees. Now that has been significantly reduced to $150 per kilowatt hour. So it means it has been significantly dropped. So this has made EVs are more affordable, and almost all the companies, they started in promoting this EV vehicle, including TVS, and all of us know that. Right. And now come to the point of the electrical vehicle, what would be the possible advantages of energy efficiency? Understanding that as if it is an IC engine, of course, the fuel tank is being filled with 100% energy as it uses the IC engine that works with converting the steam energy into mechanical energy with the thermodynamics principle, either with a 2-stroke or a 4-stroke, maybe a gas or petrol or maybe a diesel. The conversion efficiency is about just 23% as an output mechanical power that is being used to drive your drive line. And again, there would be a 4% losses in the drive line. But you can understand here in the IC engine, during energy conversion, then the energy loss is about 77%. So of course, only the net 19% of energy is being available, then that is used for the aerodynamics and rolling as well as braking as well. And this is what the running cost is quite higher for IC engine based vehicle. Of course, this may be the case for 300cc engine vehicle for the highway driving. And now understanding that, and we are going to replace the IC engine with the electrical motor using the battery, right? So this is what the combustion, as we have an engine with engine, it has the source of power for the fuel. That feed fuel, then that makes the combustion with either 2-stroke or 4-stroke, then that drives your engine, so that it tries to get the mechanical energy that is being given to all the wheels, so that the vehicle is able to move. That is what IC engine based vehicle. Whereas here the fuel and the engines are being replaced by the battery and the motor. Here the source of power is a battery that feeds power to the motor and generator, so that produces relevant mechanical power that is being given to the transmission system to drive your wheel. This is what the battery electric vehicle, or what is called the EVs, right? And now understanding that, as we replace IC engine with the motor and fuel with the battery, now you can see as we uses the motor having the 100% energy from the battery, then the output power is about 90%, right? So it means the power loss would be about 10%, right? So then this 90% of the power that is being given to the drive line, so it hardly produces 14% of losses. It means the net mechanical power that is available at the shaft is about 76% that used to drive your aero and rolling as well as braking as well. This is what the city driving electrical vehicle, of course, the energy is about 76%, right? So it meant that as how you could as you are in a position to replace the IC engine with what is called the electrical motor followed by a battery. Understanding that how it makes sense in best fitting into the characteristics of a vehicle, because the vehicle is typically a mechanical drive system. As a motor that converts electrical into mechanical energy, and all of us know that this energy conversion, of course, that has happened with the Faraday's law as we are able to produce the mechanical power. But how this motor output characteristics well matches with the vehicle characteristics, this is the very challenging task. It doesn't mean that use a DC motor. It is a perfect choice for the electrical vehicle, so that just having the battery, it feeds power, so that the DC motor can provide necessary mechanical power. Of course, no, because the motor characteristics is different from the load characteristics of your vehicle, right? So that is what the choosing an appropriate electrical motor to meet the requirement of vehicle is a challenging task. This is what now that the companies, the companies or the industries, they started investigating or to design such an electrical motor to meet the requirements of a particular vehicle. Vehicle may be a 2-wheeler or maybe a 3-wheeler, maybe a 4-wheeler, either LMV or maybe HMV, right? How could you choose a motor that meet the requirement of LMV and HMV? HMV is a heavy machinery, and all of us that may run for about 400 to 500 kilometers or even 2000 kilometers. But whereas the LMV, they may run for maybe 8 to 10 hours, or having the distance of 300 to 400 kilometers. Of course, the characteristics differs vehicle to vehicle. Then how could you choose an electrical motor? This is what this is what an hard hat in electrical vehicle design, right? So yes, as I told you that the electrical motors are the heart of the electrical vehicle that converts simple electrical energy into mechanical energy. That the energy is being supplied by the battery. Of course, key motor features. What are the important features of the motors we'll choose for EVs? First of all, torque characteristics. That it meant the mechanical characteristics. It means any motor you choose for EV application, that motor should possess a very high starting torque. It is a very prime requirement of choosing electrical motor for electrical vehicle. Of course, just you recall the study what you could make in the third semester in the electrical machines, what you could study about the DC series motor, right? That would be an excellent choice for this EV application, because that is the only motor possesses very high starting torque, right? So the very fundamental requirement of any electrical motor for EVs is that motor should have high starting torque for acceleration. So once the vehicle is being started, as it possesses very high starting torque, then after it moves very smoothly over a high speed, maybe about it's about 3000 RPM of the electrical motor. Of course, the torque would be much less. This is what the vehicle is running at a very high speed. That is what smooth torque delivery across the speed, right? And efficient. Choose a motor, it should be very efficient. So it means it's a very critical factor for maximizing the range, and especially at the cruising speed, as you are running, as the car is moving at 200 km/h. How would you choose the motor? It is energy efficient. It's very important in designing the motor for a vehicle if it is running at highway about 200 km/h. How the motor should have the characteristics, because the motor is running, the vehicle is running at a very high speed, it possesses very minimal speed. This is what the mode is, what is called a constant power mode, as we can say, or what is called a constant HP mode. That makes sense in efficient operation of the motor or the vehicle that runs at a very high speed and weight and size. This is very contradictory to each other, right? Because if the vehicle is overweighted, right, it cannot run at a very high speed. Right, and of course the size is quite bulky. But if you could choose the vehicle and having a lighter in weight, use a kind of any fiber material, it makes sense in reducing the size. Of course, the lighter motors improve overall vehicle efficiency, and moreover, it runs at a high speed. This is what. And the cooling system. It is very important thing in designing electrical vehicle is that how could you choose or how would you design the cooling system? We never feel that the cooling is essential for electrical motor. 100% it is essential, because electrical motor, they're prone to damage because of very high temperature rise inside the motor, because of the excessive heat loss produced in the rotor as well as in the stator in terms of iron loss as well as copper loss. That is what. So motor generates very high heat, and especially it run at a very high speed, it requiring efficient cooling to maintain the performance as well as the longevity, right? So these are all the important features of electrical motor while choosing for EVs applications, right? Yes, now come to the point. How would I select the right motor for EV? Right, of course, according to these four important aspects, maybe application. Yes, what may be the choice of motor for EVs? Application may be a passenger car, or maybe a commercial vehicle, or maybe performance car. Right, or maybe a two-wheeler, or maybe a three-wheeler. That is what the application. So it should be application specific, right? And second, performance requirement. Yes, what would be the performance requirement of your EV? Acceleration. So as the vehicle starts moving moving in the city, then the motor should have the characteristics to provide uniform increase in the speed along with the constant torque. Right. Once the vehicle it's away from the road, away from the city, as it is going in the highway, then it is to run at a very high speed. It should have a very minimum amount of torque. Right. This is what the performance requirement. What would be the acceleration? What would be the top speed range? Right. And for the cost and availability, yes, how would you design a motor which is very cost effective for EVs? As I said, EVs, the cost 30% for your battery and 40% for your motor. So overall, battery with motor that accommodate about 70% of your total cost of the electrical vehicle. Would you please imagine that? How would you reduce the capital investment? The design of the optimal design of the battery and optimal design of electrical motor. That it makes sense in very cost-effective design of electrical motor for EVs, right? That is, and energy efficient goal. Yes, how could you achieve the energy efficiency? How could you maximize the battery utilization? How could you charge the battery in short duration? Still, it should not produce more heat. You know, because as and all of us know that even whatever the batteries are commercially available for either 2-wheelers or 3-wheelers, you know, they last hardly for 36 to 48 months, not more than that. So it means you are in a position to replace the battery by a new one, maybe after 3 to 4 years. You could imagine that again it occupies 30 to 40% of your total vehicle. Think of the resale of your car after 4 years if your vehicle is EV. I mean, understanding the depreciation that because of the battery, after 4 years, the battery is gone, you are replacing the battery. During the time, your 4 years old EV, the cost may be at par with your actual cost of the new battery. This is what, yes, the choosing a right motor for EV that makes sense in the form of application, in terms of applications and the performance requirement, cost, availability, and energy efficient goal. Yes, now come to the point. As I told you that application, yes, what may be the application? As I'm choosing the motor for, it's a 2-wheeler. Let us assume that I'm going to design a TVS, IQ. There is a vehicle recently launched by TVS, you know, that is called IQ. With the 2 types of power ratings, 2.3 kilowatts and 3.2 kilowatts. Right. Now, you please understand that how would you choose the motor? First of all, you should understand the fundamental. What fundamental it is? Electrical motor. Of course, it converts electrical to mechanical energy as it is being converting capital P into HP. What is capital P? It's a multiplication of voltage and current. It's an electrical energy. Output is what? HP. What is HP? Horsepower. So horsepower, that it meant multiplication of torque and speed, right? So you are converting volt ampere into torque speed. Then of course, how you could choose that torque speed characteristics at par with the vehicle characteristics. Now let us understand that 4 important region of operation of any electrical motor for EV. Let us assume the motor is being used for electrical vehicle that runs at a variable speed. Yes. Now the vehicle, once the vehicle is being started, right? You start by pressing the button, that is start. And now vehicle is able to move, right? So at the time of starting, as we use the electrical motor with the battery, so battery that feeds power to the motor at the time of starting, and all of us know that motor should possess very high starting torque. Understand it here at 0 speed in the x-axis, you can understand that the torque would be higher because the torque produced by the motor should be very high at the time of starting, but still the speed it remains 0. This is what is called the starting condition or during standstill condition. So at a standstill, as the motor it possesses very high starting torque, then the car is able to move from the starting point. Right now, what happens slowly after that? You are changing the gear from neutral to first gear. Yes, now you are changing the gear from neutral to first gear. Now the vehicle is being slowly moving. You are accelerating, right? Vehicle moves slowly and it increases the speed. You can see that in the x-axis the speed increases gradually. Of course, why the speed increases gradually? Because you are increasing the voltage supplied to the motor, right? So now voltage also increases linearly. The speed also increases linearly, right? Now you can see the red line. Whereas the motor should maintain the same torque. Whatever the torque available at the starting, the same torque should be maintained till the motor reaches its rated speed, what is called the base speed, right? So once the motor it reaches the rated speed, or the vehicle reaches so very reasonable speed of maybe 40 km/h, then after what happens, you are further increasing the voltage. But please keep in mind that. So while you are increasing the voltage from 0 to rated voltage, you are able to increase the speed from 0 to rated, but you are keeping the torque constant. But however, the current has to be maintained constant during this region, what is called the constant torque region. So during constant torque region, the current has to be maintained constant. If not, during when the motor moves or when the vehicle moves at the speed slowly increases, it increases the current is supplied by the motor, then obviously it increases the losses. That is what you are able to control the current supplied to the motor, whereas you are increasing the voltage. Now keep in mind that you are choosing the motor for the application during the starting from 0th gear to first gear, from neutral to first gear. The motor current should not increase, it has to be maintained constant, whereas the voltage should increase linearly. Think of, you cannot straight away giving a supply to the motor through the battery. It is not possible. Why? Battery supplies the power straight away to the motor. You cannot control you cannot maintain the current constant, whereas you cannot increase the voltage linearly, because battery is a constant voltage source. It provides a constant voltage, but whereas the motor needs a variable voltage according to the speed requirement. This is what no battery can be directly feed power to any electrical motor, and EV invariably requires power electronics converters between the battery and electrical motor. This is what you are able to get a current control along with the constant torque mode. So once the vehicle or the motor reaches the rated speed, further increasing the voltage, you cannot increase the voltage. Why? The motor, it reaches its rated voltage, right, according to the nameplate. Further you cannot increase. If you increase the voltage beyond its rated, obviously it causes the problem of thermal stress on the insulation, then the coil member increases the copper loss eventually, so you have to replace the motor. This is what during the zone when the motor speed increases, it increases rated. You can see the horizontal red line. You are able to maintain the voltage constant. You cannot further increase the voltage to increase the speed, whereas the motor possesses such characteristics that by increasing the speed, you are able to reduce the torque. You can see that. You can see that the curve is decreasing. This is what the characteristics it possesses. Increasing the speed causes decreasing speed, so decreasing the torque, so that it is able to maintain a constant power. That is what is called HP. Right. This is, these characteristics, if you are able to understand very clearly, you understand dynamics of electrical vehicle. If you don't understand this four region, right, you cannot understand what is meant by electrical vehicle. Keep in mind that this point is very important thing. So now, as the vehicle is running at a very high speed, maybe in the highway, from 40 km/h, now the speed increases drastically to 200 km/h. You are increasing the speed, and the vehicle is running in the outside of the city. Now the torque decreases drastically. It meant the motor should, the vehicle should have a light weight. Then only this region you are able to achieve as increasing the speed beyond its rated, but still you are able to reduce the torque. This region is what is called the constant power region. So again, how could you achieve this constant power region when the motor is running at a very high speed with a reduced torque, or when the vehicle is running at a very high speed outside of the city? Still the voltage keeps constant, but further you have to maintain the current constant as well, but you have to maintain the constant power region. This is what we invariably need power electronics converter. So electrical vehicle, it meant the mechanical system is an electrical motor powered by a battery, but still we need power electronics converter with suitable control. Then only you are able to achieve these four important regions of operations. Keep in mind that current limit during constant torque mode, voltage limit during constant HP mode. So eventually you need power electronics converter with a closed loop control. You are able to control both the torque as well as speed independently. This is what this mechanism cannot be worked with the open loop control, having a manual control of like a hydraulic control or maybe a kind of gear arrangement. So this is what we require power electronics converter, that is uses with a controller like a digital control, so that can be embedded inside your vehicle under the seat, so that you are able to maintain, and you are able to maintain the smoothness of the speed. So the range of constant power operation depends primarily on the particular motor type and its control strategy. Keep in mind that here the role of electrical engineer. Right, the design may be from mechanical point, but still design of motor still it's coming out of electrical engineering. So the role of the electrical engineer is to design an electrical motor to meet these requirements for EV applications. Right, this is what, and this achievement of changing the current as well as voltage that is being given to the electrical motor possible by having a closed loop control of any electrical. Of course, in the conventional vehicle, the speed controller is the driver. You are able to, change the speed by changing the gear arrangement. But this is not the case in the electrical vehicle, because electrical vehicle, the speed control is automatic. That is what you can have. You are able to sense the speed of the motor by having this speed sensor. Then the actual speed is being compared with the reference speed, and it produces an error. The error is being given to the controller. Let it be a linear PE controller. It produces the torque reference. Then the torque reference is being given to the torque controller, so that you have an inner current controller. So that senses the supply current, that is called IA. Then the torque controller that produces the reference current. Then the reference current is being compared with the actual current. You are able to give to the DC to DC converter, so that it produces the variable voltage to the motor. Then as the voltage is being controlled, you are able to control the speed as well as torque. This is what the closed loop control of any electrical vehicle. Of course, in a sophisticated vehicle control, the speed controller is partly influenced by vehicle control as well. Right. Now, as the technical requirements of electrical vehicle, as we could see that the electrical vehicle should have the requirement with the variable torque speed range. As I told you that, high torque at low speed, right, inside the city, and wide constant power range when the vehicle is running outside of the city. This is what now most of the electrical vehicle are being launched with the two types of mode. One is called the city mode, other one is what is called the eco mode. Eco mode, that meant economic mode. So it means inside the city, the vehicle can be running in the what is called the city mode, so that there could be a kind of fuel economy. And further, so the same vehicle is running outside of the city, you can change the mode to what is called eco mode. So there would be a kind of energy saving with eco mode. And further, now vehicles are coming with the cruise control. So it means you can fix the speed of the motor when the vehicle is running at a very high speed on the runway. For example, it is going in 150 km/h. You can set the speed with the help of cruise control as well. This is what. So variable torque speed operating range is very essential. Of course, there would be a compactness with the low weight, so that the vehicle is able to run at a very high speed in the highways. And of course, it should be energy efficient. Of course, the fast torque dynamics. It is very important. So while the speed variation, or while you are able to control the speed and torque, there will be smooth variation of speed and torque with the help of power electronics, right? And of course, it should not cause any low acoustic. It should not cause any acoustic noise while changing the speed, and of course there would be a concern about the reliability and robustness as well. In addition to that, there would be regenerative braking because of thanks to power electronics with electrical machine. So as second speed, the motor is able to operate as a generator, and then the energy may be fed back to the source via power electronics converter. Of course, the converter should have a bidirectional power flow. And the technical requirements of the electrical vehicle, the motor in terms of torque, in Newton meter, speed maybe in RPM, or maybe km/h, then the size and what would be the weight in terms of kilogram, then the efficiency maybe about 80 to 90%, and the power, what would be the power rating, and that is what we call it as a HP, and what would be the cooling mechanism, then the acoustic noise level, then operating temperature, lifetime, and the cost. These are all the technical parameters of technical information on the electrical vehicle. Right now, as I said, there are two types of mode, as it is a constant torque mode and a constant power mode. You can understand that how you could be able to achieve the two type of torque. And for the particular speed, you can see that, and as in the left side, there could be a torque for 200 to 500 Newton meter, there 10,000 to 20,000 Newton meter. Right. And maybe on another side, as we have the variable speed with the two types of torque, or for a particular torque, maybe 10,000 to 20,000 RPM, or maybe 1,000 to 2,000 RPM in the wheel, or that may be the motor. Right. And this is what, as you can understand, what would be the wheel efficiency, and what would be the speed, and the corresponding radius, and the wheel efficiency. Of course, as any electrical motor that is being used for electrical drive system, of course, it should have a variable speed torque characteristics. This is what you understand, that here the torque speed characteristics, it has that here the comparison is being made between the IC engine as well as electrical vehicle. You can understand that in the IC engine we use the gear arrangement. You see that there is a discrete changes in the speed from first gear to second gear to third gear to fourth gear. That is what. But whereas this is the discrete in nature, whereas in the electrical vehicle, see the variation of the speed and torque is very smooth. because of power electronics based electrical motor with the closed loop control, right? So of course, as an advantage of electrical motor is that operation from standstill, as you are able to operate at a very high starting torque with minimum torque at a high speed. It is higher dynamic response and very quiet and very noiseless operation, and there will be no COT emissions as well. Right, this is what, according to the discussion made in the previous slide, then the electrical motor that is being used for electrical vehicle, it should possesses three important characteristics. One is what is called a constant torque regime, and the second one is a constant power regime, and the third one is what is called a reduced power regime. So this is a very challenging task, especially choose the electrical motor for sports car. Right, as we call it as SUV, or maybe for any sports vehicle, and designing an electrical motor to operate in the reduced power region, still it is a very challenging task. This is what nowadays we may go with the permanent magnet synchronous motor. Maybe it is a synchronous reluctance motor, or maybe switched reluctance motor. That and all we shall discuss about, because here the motor is able to run beyond its critical speed. That the speed, what is called the critical speed, because the critical speed is that is the maximum speed. It is maximum speed of the electrical motor. It has certain limitations beyond this critical speed, because the motor may lose its control as it is running at a very high speed. There may be a mechanism of high speed that also produces the more iron loss that increases at the speed. Right, and also it increases the copper loss because of increasing the current as well. Right, but still, and the motor should have been designed to meet these three important requirements. Right, now according to these characteristics, now we are going to choose the motor. Right, what motor is the right size for EV, as I told you, in terms of application. Now let us see the general classification of electrical machine. What are the types of machines are available in the market? Maybe a static field called the DC machine, having a DC supply powered by a battery. Maybe there are three types, maybe a wound field or permanent magnet, or maybe a universal machine, as they are powered by a typical DC supply. Maybe a rotating field with the AC. That a rotating field means it's a revolving field. Maybe a synchronous machine, or maybe an induction machine. The synchronous machine further are classified into wound rotor, or the wound field, or maybe a permanent magnet, or maybe an induction machine. Basically, they are asynchronous machine. They always, the motor speed is less than the speed of revolving magnetic field. Maybe a wound rotor, or maybe a cage rotor, or maybe cage type single phase motor. Right. So now, according to this, still the choice maybe with the converter fed or power electronics fed drive, maybe a servo DC machine, or maybe the excited machine in the form of synchronous with the power electronics converter fed servo permanent magnet, maybe a brushless DC motor, or hybrid synchronous, or maybe transversal flex synchronous motor. Maybe an unexcited motor uses the magnets, maybe a static motor, a synchronous reluctance motor, or a switched reluctance motor. Right. As far as induction machine is concerned with the power electronics fed, maybe a servo induction machine, maybe a doubly fed, or what is called a slip-in induction machine. Right. These are all the different types of electrical motors being commercially available for EV applications. Right. Now we will discuss one by one. The first motor, the very first machine that is being used for variety of applications, including the industrial automation, or maybe the industry, called the DC machines. Further, the DC machines, as you can see, what would be the DC machine structure? It has an armature as well as field. Right, that the field that uses the winding that wound on a magnetic core, that of course typically a stator. Then the rotor, it's a rotating machine, but still as it needs excitation on both stator and the rotor. Armature on the field, it is able to produce energy. That is what DC machines are basically called as a conduction machine, as they need excitation on both stator as well as armature. That is what they call it as a doubly excited machine. Right. But however, the merits of the DC machine is a very simple control, because as you are able to control the speed and torque with the help of controlling the excitation current, you are able to control the speed, and by controlling the armature voltage, you are able to control the torque. Right. So, and this is what the simple mechanism of controlling, the mechanism of controlling and torque, but still it needs a very simple converter. Right. What are the demerits? That the larger in size, because of commutator. Right. So because of the commutator, that is called a mechanical rectifier, as the torque is being unidirectional, invariably the commutator with the brush assembly or are essential for producing the unidirectional torque, right? And this is what, of course, the size could be much, much bigger, and the maintenance is required because of the use the brush as a sliding contact. Of course, the overload capacity is here limited because of the brushes, right? And this is what, but still, these motors, as I told you, that the DC motors always as a reference motor for designing any advanced electrical motor, because DC motors have an excellent characteristics as far as running is concerned, because especially the DC series motor is one of the motor that possesses very high starting torque. You know, the starting torque of the DC series motor is about 20 to 30 times higher than the full load torque as compared to any electrical machines are available in the market, because the series motor is one of the best candidate for especially for the traction purposes. That is what the scenario has been started in the electrical motors for transportation, but now the scenario has gone no more DC series motor because the problem of commutator and the brushes. This is what now we are trying to emulate the performance of the DC series motor with a very recently launched or recently developed DC motors with a different name called the PMSM machine, or maybe brushless DC machine. You design such a PMSM or the BLDC machine, but still getting the actual characteristics of DC series motor is a very challenging task, because that is the most versatile motor for variable speed application. That is the only motor it possesses very high starting torque. So always we take the reference of either a DC series motor or another important motor as a reference motor, what is called a separately excited DC motor. There would be a decoupled dynamics between the flux and torque. Right, and there would be a decoupled independent control of speed and torque because of separately excited DC motor. So now the researchers, they intensively design any electrical motor having the characteristics at par with the DC series motor or separately excited DC motor is a very challenging task. This is what now the electrical motor is very popular for EV application, and especially designing such motor, the characteristics at par with the series motor, DC series motor, or what is called DC separately excited DC motor is it's a challenging task. Right. Now further, as I told you, the DC series machines for electrical drive that is using without converters. You know, this is what in the earliest 2000, in the late 19th century they used for electrical vehicle application, electric traction application, and because of what, the battery is a source directly feeding power to a DC series motor. You are able to control the speed and torque by controlling the excitation current, supply current, as well as the voltage. You are able to get the variable speed torque characteristics. See the characteristics. These characteristics are excellent choice for very high speed application, including high starting torque application as well. It possesses self-regulated torque speed curve, as you can see here, and of course it has a high starting torque with the minimum starting current. This is one of the beauty of DC series motor. And moreover, speed will be driven to equilibrium point at a high speed. It is a preferred behavior of EVs. It means when the vehicle is running at a very high speed, the EV still it should have a very steady state operation with the minimum torque. Right. The credit goes to DC series motor. Of course, very high at no load speed. That is one of the difficulties encountered in DC series motor, because DC series motor is a motor, it never be runs at a no load speed, because at no load, of course, the flux is very minimum, whereas the speed is dangerously very high. This is what DC series motor is may not be an excellent choice for the kind of autonomous vehicle like a car or maybe a kind of two-wheeler or that, because initially the no load is being available at the motor, it may run at a dangerously very high speed on the road. Right. And however, as we need the smooth transition of the speed and torque, most of the DC machines are converter fed DC machine. Of course, we use a full bridge DC to DC converter, maybe half bridge DC to DC converter, but still you are able to control both armature current as well as armature voltage, so that you are able to achieve your 4-quadrant operations, right, for motor as well as regenerative braking. All right, this is another popular motor is available in the market. Right, a permanent magnet synchronous motor. Still, they are not so very emergent or new motors, because since in the late 1980s we use these PMSM motors for almost for all automated industries, including like aircraft plants and as well as for the ship propulsion, where we need a very high start torque application, including cranes and hoists. These motors become very popular. Right, but what is the advantage of this PMSM? The characteristics are par with the DC motor, But however, the excitation here doesn't require because the rotors, it uses a permanent magnet. Whereas the stator, it has a stator winding, it needs excitation. That excitation, we provide a three-phase alternating supply, so that produces the revolving magnetic field. Still, you keep the rotor, it's a permanent magnet, it is able to produce the speed and at the same speed according to the supply. And that is what this is, the synchronous motor. It always runs at a constant speed, right? What is the advantage? It is very compact and high efficient because there would be there would be no magnetic field. It has a winding, so it uses permanent magnet. It is highly efficient. The demerit is that what, as we use the permanent magnet, that the permanent magnets are demagnetized at a very high speed. If you choose the motor for a very high speed application, if it runs at a very high speed, ultimately it may demagnetize the magnetic core. It may permanent magnet. It may cause the problem of demagnetizing, that it increases the magnetic losses. This is what high temperature sensitive, but high loss at a very high speed, as I said, exposed to the magnetic losses and the danger by short circuit fault as well. And this is what the demerit, but still we can use a power electronics converter for the PMS. So still we are able to manage the temperature and reduce losses at a high speed. You are able to provide any shoot through when there would be a short circuit. Right. So classification, PMSMs are further classified according to power to weight ratio, high efficiency, regular construction, low cocking torque, and capability of reluctance torque as well. Right. And these are the different types of classification according to these 5 important characteristics. Now you can see that this PMSM machine is being excited by a three-phase AC supply via DC to AC inverter. As it produces a sinusoidal current and the voltages, so that this motor is able to provide a mechanical power. But however, the output voltage, of course, it has a pulsed output that is called a staircase three-phase AC voltages. Of course, the current ripple that may be there, especially run at a very low speed, right? But however, sometimes we may go for, instead of having 2-level, we may use a multi-level inverter, so that you are able to shape your voltage from pure sinusoidal, right? And still the multi-level inverters are very popular for power, PMSM drive system, because by increasing the number of level, it is able to produce a sinusoidal voltages. So it inherently reduces the harmonics, as well as it is able to make smooth operation of the speed with low acoustic noise. This is what the specification of the motor currently is available in the market for electrical vehicle application. These are the typical speed torque characteristics of PMSM drive system. Right. This is another interesting motor that is used for low power application. For example, this is the motor is very popular for two-wheelers, and the TVS iQube, they launched the TVS iQube is a kind of EV that uses BLDC motor. This may be the choice for up to 10 kilowatts, and you may use a BLDC motor. This is very popular for two-wheelers and three-wheelers with an application less than 10 kilowatts. Of course, the brushless DC motor is an alternate to DC motor, that it doesn't require any commutator and a brush, but still it needs an electronic excitation. That is what you use electronic excitation to produce a trapezoidal voltage waveform to the BLDC motor stator, whereas the rotor, it uses permanent magnet. But however, as you are replacing the commutator and the brush, making the unidirectional torque, as we uses an inverter, of course, the inverter has to be used with the sensor having closed loop operation. This is what is called the electronic excitation. As you can see that it is even the current is being sinusoidal, but the back EMF, that is trapezoidal. That is what BLDC motor is it's a kind of motor that it works with the trapezoidal or the square waveform, whereas the PMSM motor, the voltage waveform is sinusoidal. Right here, this is what the BLDC motor differs from the PMSM machine. PMSM machine is a sinusoidally excited AC motor, whereas the BLDC motor is a trapezoidally excited AC motor. Right. This is what it always required an inverter with a closed loop from the speed, so that you are able to, maintain the position of the speed, position of the rotor to make the commutation. This is what you can see, that 127 kilowatts electrical motor at the PWM, that is the BMW car that uses. Right. But still now even low power application, we use a BLDC motor. Right. This is another interesting motor, and all of us know that the induction motor. You know, the beauty of induction motor is that very robust. it is essentially a constant speed motor. If you are running the vehicle, especially inside the city, most of the time, you always use the vehicle inside the city. This may not be a choice, but whereas you need to run at the highway always at a constant speed. This is one of the best choice for the constant speed application. And however, the dynamic torque control is possible by having power electronics converter. Right, but however, the demerits is that size is quite bigger, especially having the rotor bar and low efficiency at a very low speed rate. This is one of the difficulties because of high starting current. We need to have an inverter and having a minimum starting current at the time of starting. If not, it may cause more losses, and also it makes sense in producing the voltage sag when the vehicle is being charged with EVs. And the large N turn as well, that causes more copper loss, right? And this is why this induction motor is being excited with the 3-phase 2-level voltage source inverter using IGBT as a switch. So you are able to produce a sinusoidal voltage and current that is being given to the motor, but the motor speed, it is always less than the synchronous speed. That the speed is what is called the speed of revolving magnetic field. But still, you are able to get the different speed or characteristics, having a different design in the rotor, maybe a double gauge rotor, or maybe a deeper rotor, or maybe a kind of wound rotor. You are able to get different speed or characteristics. As I said, the induction motor is essentially a constant speed motor, but if we need variable speed torque, then you may go with the modified design on the rotor, maybe a double gauge rotor, or the deeper rotor, or maybe a wound rotor, or maybe a round conductor rotor as well. This is what the characteristics. Right, and this is another interesting motor is most widely used for 3-wheelers like rickshaws, right, or auto. We use switched reluctance motor. This may be the choice for the power rating between 10 to 20 kilometers. But here, the structure, it has a permanent magnet. Of course, it is a simple and very robust rotor. It uses concentrated winding on the stator, and you can see that it is a 6-pole measure having and a 6 stator winding with a 4-pole rotor, right. It doesn't require any excitation. Of course, the converter with unipolar current, it makes sense as it is working with the principle of changing the reluctance between the stator and the rotor. That is a change in the reluctance of the air gap. It is able to produce the mechanical power. And this is what, of course, it changes the reluctance way. Of course, variable phase inductance, as the inductance slope determine the torque sign. That is what excitation on one half of the entire period, but still sometimes the problem, if the motor is running at a very high speed, it may cause the problem of magnetic saturation. And again, it causes increase in losses, and also that may loses the speed control. This is what. So this may be for a medium speed application having the power rating between 10 to 20 kilowatts. This is what the switched reluctance motor as it is being driven with asymmetrical half bridge converter. And of course, here the phase independency is there because each phase only one switch and one transistor is being fired, right? So, but of course, it's a shoot through free, but it's highly reliable. And of course, and as you can understand that what will be the phase current and the voltage as well as the torque, right? And here, how this excitation is being done for producing the relevant voltage and the torque, you understand the mode. But however, here the torque ripples are highly pronounced in a reluctance motor because the problem of low speed, especially at the low speed, it may cause the problem of what is called a torque ripple, right? But however, this torque ripple also may be during the non-uniform switching of S1 and S2 along with the D1 and D2 during commutation. But of course, this motor is required very robust or advanced control technique to minimize the torque. If not, it may produce more acoustic noise, especially during low speed. Right, that is what most of the cases we may go for a direct torque control of switched reluctance motor for high speed applications. Right, this is the merits. As of course, it's a simple and robust motor. It uses concentrated winding. It doesn't require any excitation. Of course, it needs converter with unipolar current. The schematic, you understand that the demerit is the torque ripple. This is the problem, right? And however, it may produce the noise and the vibration and the aerodynamic heat. It runs at a very high speed. Of course, it may cause us more frictional and vintage loss because of torque pulsations, right? However, as the design aspect, the converter is very essential. Then only you are able to achieve unidirectional torque. But however, the position information is required. That is what we need to have a sensor to sense the speed so that you are able to control the speed as well as the position. Right. And you can see that according to the torque density per volume, And how could you choose the motor for different applications, right? Either it may be a switch reluctance motor, or what is called the induction motor, or maybe PMSM motor, or maybe the DC motor. Understanding that where you require very high starting torque, you may go with the PMSM motor, right? And where you may require a very high output power in terms of kilowatts, you may go with the induction motor, right? Understanding the output power curve for the different application. Of course, induction motor has a high efficiency at a medium speed, whereas it chooses for high power applications. SRM has a high efficiency at high speed, whereas PMSM has a high efficiency in the average speed. Right, and this is the way you choose an electrical motor for EV application. This is the comparison of different motor types according to the paper that has been published in Australian University's Power Engineering Conference, and this could be the nice comparison for the motor and the speed in terms of power rating, the speed as well as torque. This is what the EV model, maybe a Tesla, or Prius, or maybe Leaf or Lexus, or maybe a BMW or the Sonata. This is what the year of manufacturing, but still this data is quite outdated. Now you can find a number of research articles on the electrical motor for EV applications with the updated vehicle. Of course, the motor type may be an induction motor, a permanent magnet. Mostly they use as a permanent magnet motors in this period. Now you can find a switch reluctance motor is also promising for three-wheelers applications. So motor power in terms of kilowatts, you can see here what would be the corresponding maximum as well as maximum speed as well as maximum torque. Right, and this is then another type, maybe an interior permanent magnet, or maybe a switch reluctance motor, or surface mounted permanent magnet, or maybe this is another permanent magnet synchronous motor having the power rating and as well as the torques. Maximum torque. All right, and this is the power and the voltage range of electrical drive. Of course, maybe a bicycle or the scooter may require the power rating between 180 to 500 watts. Of course, the DC bus voltage would be 24 to 36. You choose the battery having the power, the rating of voltage between 24 and 36. But maybe a motorcycle that the power range may be 800 watts to 800 watts to 4 kilowatts. The DC bus voltage may be still the battery size would be about 36 to 96 volt. But according to the code, you choose the ampere hour. Right, the cause may be a hybrid power, the rating may be between 5 to 30 kilowatts. The DC bus voltage for the inverter may be between 200 to 600 volt, three-phase inverter. And EV power 45, the power rating may be 45 to 80 kilowatt, but the still DC bus voltage between 200 and 800 volt. And then most widely in the recently launched Nexon as well as the what is called the Punch, you can find the EVs having the power rating between 20 to 30 kilowatts. Right, for a bus, of course, it's coming under HMD. The power rating may be in the order of 100 kilowatts or more. Bus voltage may be between 400 to 600 volt. This is what we need, multi-level inverter for very high voltage along with the high power applications. And moreover, the railway traction, we use a few hundred kilowatts to up to megawatts range. That depends on the application as well as the type of population. Of course, the DC bus voltage may be between 500 volt to few kilowatts. But here, the multi-level inverters are very popular for feeding power to any motors used for railways as well as traction application, because here the power rating would be in the order of 500 kilowatts to megawatts level. Right, and of course, the whatever we could see the different types of motor for electrical vehicle application possesses the different speed or characteristics. The choosing appropriate motor is a very challenging task. But still, however, what would be the advancement in EV motor to make sense in cost-effective electrical motor? Of course, the integration, the compact design. Of course, nowadays, and you can have a development of integrated motor inverter unit to save space as well as improve efficiency. This is what now, of course, wheel hub motor is available nowadays for the two-wheeler and the three-wheeler. The motor is being fitted in the wheel itself along with the inverter, so that you are able to reduce the size as well as the compactness. And maybe the permanent magnet nowadays, they are very popular because of such permanent magnet material, or maybe an alternate for a rare earth material, maybe a neodymium iron boron, increased focus on motor that eliminate or reduce reliance on the rare earth magnet. Maybe they go with the ferrite magnets or maybe neodymium iron boron, right? And high-speed motors. So high-speed motors mean the motors are designed for a very high-speed application, about 20,000 RPM. The motor designed to operate at a very high RPMs, allowing for a small and lighter design. Right. Of course, we use, that is what nowadays we use the motor, the design with a kind of fiber material, so that it eventually reduces the weight of the vehicle. Of course, the in-wheel motor, as I told you, the most empowered the wheel for all wheel drive system but increase the design flexibility, sometimes enhanced material. Sometimes we may use, that is what for making the body of the vehicle like a carbon fiber or composite for lightweight components. And of course, now as AI is an emerging, and still now the control system is quite flexible and robust using the machine learning algorithm for optimizing the motor performance under varying drive conditions. Of course, it needs such a kind of robust as well as the robust as well as the precision control and for very high performance electrical motors for EV application. Of course, we need such control based on the AI as well. Right, but still beyond that, beyond that, and again, how could you optimally design the battery, and how could you choose battery? Right, that is what now again choosing the battery is not an issue. How could you charge the battery? That is what now ultra high speed charging, how this is possible. Now you use any power electronics converter, maybe a conventional silicon based or maybe a wide backup semiconductor devices. How it would make charging the battery at a very with a minimum duration. Still it is a challenging task. That is what. So in electrical vehicle, we have research and development opportunities in each and every component. Right, design of electrical motor, design of power electronics converter, choosing an appropriate design of controller, and making the integrated design. And in all, how would you make the EVs or energy efficient? How would you be able to reduce cost as well as the running cost? Right, this is what the challenging task. Right, and thank you very much for your kind attention, as I could highlight the importance of electrical motors for EVs, different types of electrical vehicles, and briefly discussed and even highlighted the advantages and disadvantages as well. If you have any doubt, please let me know. Thank you very much. Yes, please.
Participants are requested to ask their doubts. This is question session.
Yes, dear participants, if you have any doubt, please get in touch with me. And still, if you don't have any doubt, please further any collaboration.
Sir, I have a doubt, sir. Using which motor will reduce the cost of the vehicle, electrical vehicle, sir? Please explain, sir.
Choosing, this is what a challenging task, right? If you see, for example, your vehicle needs the torque of, for example, about 50 to 60 Newton meter. The power rating may be about 10 kilowatts, right? For 10 kilowatts, right, 200 Newton meter electrical motor you choose for a particular application mean. For this power rating as well as for the power as well as the what is called electrical power as well as the mechanical torque requirements. Now choosing a right choice means the cost involves, but still the performance it matters. Right. So if you choose an induction motor, it is a right choice for high power application but low speed. But if you choose a permanent magnet synchronous motor, sinusoidally excited motor, that may be the perfect choice for very high starting torque with minimum speed range. Right. So likewise, so always choosing the electrical motor optimally, it is a very challenging task. Always never trade off. You want a very cost effective motor for a very low power application, choose a PLDC motor. That is the only choice. Right. But if for a very high power application, but still the speed it is very minimum, you may choose PLDC motor. But still you wanted to choose the motor for a very high speed application, right? Like for a sports car. There you use the motor like a synchronous reluctance motor, or maybe you may choose a multi-phase synchronous reluctance motor that is able to run at a very high speed. This is what. So cost effectiveness means it makes sense overall cost of the vehicle. As I told you, 40% of the cost of the electrical vehicle it meant for more cost of the motor. 30% for your battery, remaining 30% for all other accessories. Now that 40% of the cost, choosing an appropriate motor may eventually reduce 35 to 40%. Hardly 5% you may reduce the cost by choosing an appropriate motor. Are you able to follow me?
Yes, sir. Yes, sir. Nice explanation, sir.
Yeah. Thank you. Yes, someone have
Any other questions from the participants? You may ask. Any other questions from the participants? You may proceed.
Yes, Vishal has raised a hand. Please tell me, what is your doubt?
Sir, unmute your mic and you may ask your question, sir. Vishal, sir.
Okay, very informative session, and thanks, Dr. Ganesh Kumari. Thank you very much, dear participant. You are quite exhausted because of the previous session, and again, again another session, and almost you could spend time completely for 3 years for this both session. Of course, you are quite overwhelmed with different learning mechanism with the different titles as well. And thank you very much for your kind attention. And you can go through my profile and it will get your Kanchipuram. Any doubt or any support, you can send an email to me. I will respond to your email. Okay. And my best wishes for the organizers as well as the participants. Have a happy learning, and thank you very much.
Sir, thank you very much, sir. Thank you very much for your nice presentation, sir. Thank you, sir.
Okay. Thank you very much. I'll share the slides tomorrow. Please allow me to view. I will share tomorrow. Thank you very much.
Okay, thank you, sir. Thank you. Thank you.
Vinesh, sir,
Participants are registered. Yes, sir.
shall we conclude the session, sir?
Yes, sir. Okay.
Nice. So as we come to the conclusion of this insightful session on electrical drive technology for EV applications, it is my privilege to extend a heartfelt vote of thanks on behalf of SRM Madurai College for Engineering and Technology and the entire organizing team of this adult online 6 days FDP. First and foremost, I express our sincere gratitude to our esteemed resource person, Dr. T. Chettibabu, Associate Professor at IIDDM Kanchipuram, Chennai, for sharing his profound expertise and valuable insights with us today. Sir, your detailed explanation of motor features for EVs, selecting the right motors for EVs, technical requirement of vehicle drives, and the type of electric motors in the context of EV applications has been truly enlightening us. Your dedication to research, innovation, and teaching is inspiring, and we are grateful for the knowledge you have conveyed to us. I would like to also extend my appreciation to our respected management, faculty members, and all the participants for their active engagement throughout the